Imagine if every doodle, every line you sketch on a piece of paper, could become a rhythm, a melody. Just like placing a record on a turntable. That's the idea behind my project, an interactive record player that transforms hand-drawn patterns into real-time sound. This was our initial concept design. As you can see, our system is made up of 3 key components. First, the light source. It shines down from above and creates shadows wherever the paper has dark markings. This helps isolate the drawn areas clearly from the background. Second, we have the light sensors. These are positioned underneath the spinning disc, and they constantly measure the intensity of light passing through each point. Whenever a dark area blocks the light, the sensor detects a drop. Third, the servo motors. Each one is paired with a small mallet, and when a sensor detects a shadow, the corresponding servo is triggered to strike a xylophone key. In summary, this is how the system works. You draw on a rotating disc. The overhead light casts shadows onto the sensors. The sensors translate those shadows into signals, and the servos convert those signals into sound. Your drawing becomes a melody. It turns out, syncing a spinning disc with accurate light detection, servo control, and musical output isn't easy. We had to iterate a lot. One of the first challenges we faced was power supply and voltage distribution. In our initial setup, we connected 4 servo motors directly to a single Arduino board, without any external power source. This caused a major issue. Only the first servo worked properly, while the others either lagged or didn't move at all. We quickly realized that the Arduino couldn't deliver enough current for multiple servos. According to our test, the Arduino board can only provide enough current for 2 servo motors. To solve the power issue, we decided to limit each Arduino board to just 2 servo motors. This worked. The servos were now stable and responsive. But it came with a cost. With more boards and more distributed wiring, our setup became much more complex. The number of cables doubled, increasing both the physical clutter and the risk of short circuits. The second challenge was how to mount the servo motors securely. In our design, each servo needed a stable platform to prevent it from moving while striking the xylophone. Initially, I proposed using 3D printed mounts, adjustable in both height and angle, which would make testing easier by allowing us to fine-tune the striking force and direction. However, with 15 servos, printing 15 custom mounts became too complex and time-consuming. So we switched to a low-tech but effective solution: foam blocks and hot glue. To improve the appearance, we wrapped each mount with black cardstock to give it a cleaner, more finished look. During testing, we discovered another issue: the black marker we were using wasn't blocking light effectively. Although it looked dark to the human eye, it still allowed too much light to pass through, making the changes in the light sensor readings too subtle. As a result, the servos often failed to trigger as expected. To fix this, we switched to acrylic paint pens, which provided a much more opaque and light-resistant coating. With acrylic paint, the difference in sensor readings became much clearer. This allowed us to set a more reliable threshold for triggering the servos, and improved the overall responsiveness of the system. Let's take a look at the final display effect. Looking back, I'm proud of what we've achieved with this project. We built a fully working interactive system that translates drawings into sound, using affordable components and a lot of creativity. Throughout the process, I learned how to iterate, how to problem solve under constraints, and how to bring physical computing ideas to life. If I were to improve the project, I'd start by enhancing the accuracy of the sensors, possibly by using infrared or capacitive touch sensors instead of relying purely on light. I'd also redesign the servo mounting system to make it modular and reusable, reducing setup time.